Good morning, dear students. Today we are going to discuss about the next topic, what we discussed to the previous topic. Next topic in the sense here, see, we are discussing about the treatment works. In that, we have seen the sedimentation, and we have completed the topic sedimentation. Completed in the sense, we've only completed the principle of sedimentation, and also we have completed half part of the design of sedimentation. See why I went back for this slide for today's session is, I said that the specifications, when we are discussing about the specification to construct these treatment plants, all the units, see different units, one, see in the sense, different units, 1, 2, 3, all you are observing, you are visualizing different units in this particular picture. All these units are constructed side by side. Side by side, and after sedimentation, the next step is coagulation. After coagulation, filtration. After filtration, water softening. See, all the steps and all the units must be constructed side by side. See here, side by side, and the water must be flown, the elevation where the water can enter into the next unit based on the gravity. We must take proper care, or else we must take the precautions in such a way the water can move from one zone to another zone based on the gravity, not by pumping. That is the second specification. And the third one is, there should be a proper planning for constructing these units, and there should be a feasibility for future expansion. See here, quarters. There should be a place for staff quarters, and complete atmosphere conditions must be clean in and around the treatment plants. That's why, or else those points we have discussed in the name of specifications for treatment works. Okay, let me discuss. See here, all these are the specifications for treatment works. We have seen side by side, based on the gravity, proper plan, future expansion, staff quarters, and hygienic atmosphere. Right? See here, today we are going to discuss about the next topic. See, up to settling zone, we have seen the next topic is design of sludge zone. I said that once the drag force and frictional forces becomes zero, the particles will settle with an uniform velocity. That velocity we just named it as settling velocity. See here, once they are settling, all the particles at the bottom, we just name them as sludge. All those particles, we may call them as sludge. See here, the sludge must be taken away without creating disturbance to the settling particles. How can we achieve? By keeping the sludge zone slopey towards the center or towards any particular side. See here, this after, see, this is here, have a look over here. This is sludge zone. See here, the settling particles, or else the particle will settle here. The zone we are constructing slopey manner, there the flow is controlling by a wall. Through this wall, with a pipe, the sludge will be taken off and the flow will be controlled by sluice wall. Understand? This is the slopey wall. of sludge zone. From this wall, the sludge enters into the sludge pipe. The sludge pipe is towards the outside, which the where the flow will be controlled by sluice valves. What is this wall and what is the meaning of gate wall, sluice wall? All we discuss in the coming topics. Understand? See here, sludge zone. The first point is without creating any disturbance to the settling particles. The settled particles, we name it as sludge. What the sludge will be taken off without creating the settling, without creating any disturbance to the settling particles. How we can achieve? By keeping the slopy flow towards the center or towards at one side. Understand? This is about the sludge zone. And the next one is design of outlet zone. See, at the time of designing sedimentation tanks, the way we have taken specification to design inlet zone, in the same way, we must concentrate on outlet zone also. There are different models. See here, this is A model, and next one is model B. So water when be taken off without creating any disturbance to the settling zone. See here, the water will be taken off. See here, see, this is inlet and water will be taken off within a telescopic tube outlet. This is the outlet. Through this, the water will be taken off from the outlet zone. See here, in the inlet zone, the water enters. What is the fundamental points which we remember? The settling particles should not create any disturbance to the settled particles, and the water can distribute uniformly. Water will distribute uniformly around the tank. And these two, and design of settling zone. When the particle will settle, the two forces, whenever the two forces become zero, slowly the particle will settle. What is the formula to adapt for designing the settling zone? L by V greater than H by Vs. Next one is sludge zone. The sludge zone must be a slopy bottom towards the center or towards one side. All the settled particles, name them as sludge, and the sludge will be taken off without creating disturbance to the settling particles. Through the pipe, which has an outlet to the outside, the sludge will be taken off. Next one is, this is about the sludge zone, design of outlet. Those 2 points, what we discussed in the for units, inlet, water should distribute entire the tank or else around the tank or else entire radius of the tank. And here the point is the water, that the outlet should not create any disturbance to the settling particles. There are 2 models. Here also we're discussing 2 models. There are different models. In the one model, see through here, through this point, the water will be taken off and water will enter into the next unit. Coagulation, next unit, coagulation. See, by using and so by maintaining telescopic tube outlets also, the water will be entered into the next step. That means what we are doing here, water has collected from the sources through inlets. We have seen that reservoir intake, lake intakes, canal intake, all in those intakes. Once we collected the water, if you have any particles whose specific gravity is more than the liquid, will settles on the bottom. We are not creating any disturbance. Based on the gravity, the particles will settle. This is first step. Simple, you maybe understand. Once we have we may be observed regularly. When you are observing water body, all the particles or else weighted particles will settle bottom. Based on the gravity, we are just allowing those particles to settle, and those settled particles will be taken off in the name of sludge. Next is types of sedimentation. What is sedimentation here? We have seen what is sedimentation. See, have a look here. Settling of particles at the bottom of the tanks or catchments due to the differences in specific gravity of liquid and those solid particles. That is what about sedimentation. Now here, the topic is types of sedimentation. Rectangular tanks. First one is rectangular tanks, and next one is circular tanks. Third one is hopper bottom tanks. Now we'll see one after one. What is this mechanism in every category? The rectangular tanks. Simply have a diagram here. Have a look over there here. I mean, have a diagram in the sense, have a look on this diagram. See here, through inlet, water flows by crossing different baffles. While water moves through the inlet, the velocity of water is fixed in such a way the particles will settle on the bottom. Slowly, water moves. Why we kept baffles in the sense the traveling area is increased. While the traveling area is increased, where the water speed of the water is fixed in such a way, the particles will settle at the bottom based on the gravity. What is sedimentation? Settling of particles on the gravity. Simple in one word. We have seen the technical definition in the earlier itself. See here, while the water is moving or is traveling along these baffles, where the speed of water is fixed or is fixed in such a way, the particles will settle the bottom. Likewise, the water flows in such a long distance and comes out through outlet. While the water is traveling by crossing baffles, the particles will settle on the bottom. These are called as rectangular sedimentation tank. See here, these are mostly suitable for plain sedimentation where the water flows at uniform velocity. I said that velocity will be fixed or maintained. The length of traveling water is increased. How we increase? Simply by keeping baffles. See, at the bottom of every baffle zone is designed with center slope, which is connected to under bottom sludge pipes. We have seen this is the bottom slope like this. Every step, everywhere, bottom of every baffle zone, okay, slope, center slope, okay. The sediment from the bottom will be taken out through the sludge pipe. We have seen earlier itself with an hydrostatic pressure where arrest which may not create distance to the water flow. The entire water flow will be controlled by gate wall. See, we have seen we have crossed we have crossed one wall, sluice wall. Here we are discussing, or as we encountered one more wall, gate wall. We'll discuss the next topic. See here, what is sluice wall, what is gate wall, what is check wall, we'll discuss. There is a topic by name walls. There we'll discuss. There is a topic joints we have seen in the second unit. Same ways, walls are there. We'll discuss. See, this is about the rectangular sedimentation tank. Next one is circular tanks. See here, this is rectangular and it is circular. Water flows in a circular manner where the gravity particles will settle or where the weighted particle will settle based on the gravity. There are two types of circular tanks, radial flow sedimentation tank, and one more is circumferential circular flow sedimentation tank. We'll discuss what is what. See, a radial flow sedimentation tank, nothing is there here. Simply, you must learn diagrams, especially in E1. Every topic consists diagrams. You must make sure to learn all the diagrams. when we gone through the topics what we discussed, you may be understood that all the topics are in association with all the topics are associated with almost all the topics are associated with diagrams only. So this is here, I mean, this is here in the sense radial flow sedimentation. See, it is the inlet. Through the inlet, water enters like this, and what once it enters, the arrangements will be there. Water flow, or else water will redirects its direction and flows towards the chamber. Understand? Water enters through this. See, have a look here, inlet, and here water redirects water in the sense the direction of water is redirects. See here, have a look here, like this, water flows. As the water flows radiusly from the deflector box toward the circumference of the tank, all the suspended particles are settled down on their gravity, and the clear water goes out through the outlet. See here, through the inlet, water is moving in this direction, right? And from here, the water takes another direction, reverse direction, and flows out. This is about the deflector chamber, and this is the arrangement where water will be, or else this is the device through which water will moves and the particles will settles at the bottom. Understand? From here, water enters to the outlet zone. Through the outlet, water will be taken off. This is the water level. This is water level. See here, water, see here, takes the another direction. Understand? And from here, the water will taken off, or else from the outlet, water comes out. This is water level, and it is the gangway. This is radial flow. See, radial flow in the sense from one particular point, water will be distributed radially. See, one particular point, water will be distributed radially, and this is the gangway, and it is meant to, it is meant for maintenance works. Did you understand? So this is about the radial flow sedimentation tank. The scrappers arranged to move with minimum velocity. I said this, these are the scrappers. Scrappers, I said that water earlier, this is an arrangement, for water flow. Scrappers arrange to move the water with minimum velocity as the water is passing or is distributing radially. See here, I see distributing radially, the particles that are associated with those water droplets moves slowly downwards, and the water flows out through the outlet. This is about the radial flow, or else radial flow sedimentation tank. Did you understand? These are, see, through the inlet that is placed in the deflector box, water enters into the deflector box. This is the deflector box. Okay, and goes out through the outlet. This is the outlet. Water enters from this point. Radially, water will be distributed. These are the scrapper to maintain the velocity. Through the outlet, water will be taken out, and it's the gangway, which is meant for maintenance, or is for conducting, or else for maintenance purpose, or is for maintenance works, the gangway will be used. This is about the circular radial flow sedimentation tank. One more model is there in the circular tank. We'll discuss in the next class. Hope you understood. Today we have discussed about the sludge zone and outlet zone, and we are here types of sedimentation. See, we have seen rectangular tanks where the water will move and whose velocity where the water velocity is fixed in such a way water can settle at the bottom at every baffle zone. Through as the baffle bottom area of every buffer zone is slopy. That slopy area connected to the sludge pipe, this type of sludge pipe, simply the settled particles will be taken off. This is about the rectangular sedimentation tank, and it is about the radial flow sedimentation tank. If you have any doubts, you please contact me in the domain whatever feel convenient, either phone, message, or mail. Thank you.